Okay, so in this video we're going to use De Moivre's formula to calculate 1 plus I root 3 to the power of 5. So where do we start with that? So first of all, as this is a complex number, we'll let z equal this complex number. So z equals 1 plus I root 3, where z is in the form of a plus ib. So therefore our a is 1 and our b is square root of 3. Obviously the I is the imaginary coefficient, which is square root of -1. Okay, so De Moivre's formula says that z to the power of n equals r cosine theta plus I sine theta all to the power of n. Okay, so looking at our question here, we know what our z is, so that's z. Our n is 5, so let's just write that down there. So n equals 5. Now what we're missing is what r is and what theta is. So to make this easier, we'll just draw this on the Argand diagram. So we've got real numbers and imaginary numbers. And what we can see is that our a is our real part, that is 1. So that will end up here somewhere. And our imaginary part, which is b, is square root of 3. So it's going to be up here somewhere. So that's about there. So therefore our imaginary number, our z, is this. Okay. We need to find out what r is. That's our modulus. So the modulus of any complex number, that is found out as square root of a squared plus b squared. Okay, so this is our a, and our b is square root of 3. So let's just plug that in there. So that's square root of 1 squared plus square root of 3 squared, which is square root of 4, which equals 2. So that's our radius. So just write that in there now. Radius equals 2. Next we need to find out what the argument of this complex number is. So our argument is this one, which is basically the angle from the real axis going in anti-clockwise rotation. So to work out what that is, just go to SOHCAHTOA. Tangent theta equals root 3 over 1, i.e. opposite over adjacent, yeah? So tangent theta equals root 3. So therefore we need to find the inverse tangent to know what our angle is. And the inverse tangent of root 3 is pi over 3. So now our theta is pi over 3. Okay, right, now we're in a good position. Now we can work out what all these things are now. So let's take this formula here, starting down here, and let's go for it and see what we get. So z to the power of n is r, which is 2, cosine theta, which is pi over 3, plus I sine, and the angle will always be the same, sine pi over 3. And that's to the power of n, which is 5. Okay, so now what we need to do is just distribute this 5 into here. Oh, too far, into here. Okay. 2 to the power of 5, we know what that is. That's 32. How do we distribute this 5 into here? Well, instead of raising this cosine to the power of 5, we just multiply it by 5. So that's cosine 5 pi over 3 plus I sine 5 pi over 3. Okay, angles are always the same. So now what we can do, we've got this, we just need to calculate these two now, cosine of 5 pi over 3 and sine of 5 pi over 3. So 5 pi over 3 is going to be somewhere down here. So this will be our 5 pi over 3. You can just see what the angle is there. Okay, so cosine of 5 pi over 3, that's going to be positive. So that's 32 times 5 pi over 3 is going to be 1/2. Basically that's 1 over 2, so that's the adjacent over the hypotenuse, and then plus I sine of 5 pi over 3. Again, this time we've got opposite over hypotenuse, so the opposite is going to be negative root 3. So this is plus root 3. Here we've got negative root 3. So that's now going to be negative root 3 over 2. Okay, let's see what we can do here now. Let's distribute these into the formula here. Let's take the 2 out, so then we end up with a whole number. So we get 16, 1 plus I of negative root 3. So now we can get this negative into here and turn it into Cartesian form. So we've got 16 times 1 is 16. 16 times negative I root 3. So that's minus I 16 root 3. So that's our answer in Cartesian form. Okay.